So what is measures of dispersion? It is also called as measures of spread or measures of variability. Either measures of spread or variability or measures of dispersion. They use these three terms. Okay, but most of them, to my knowledge, they use either the dispersion or spread. What is the measures of spread? So this is the one they use it. But all these terms refers the same. So far we discussed about the measures of central tendency. As part of that, we discussed about what is mean, median, mode. So now we are going to learn a different topic by the name of measures of spread or dispersion. Both the measures of central tendency and dispersion falls under descriptive statistics. This you remember it. The measures of central tendency and measures of dispersion or spread falls under which category? Descriptive statistics. Okay. So now the question is, why should I learn measures of dispersion? I know the measures of central tendency. With that itself, can't I make the business decisions? Won't it sufficient to make all the business decision? That is not possible. By learning the measures of spread, with that, measures of central tendency, with that alone, you cannot make all kind of business decisions. The measures of dispersion describe how the data is spreading, how much the data is spread out. Okay. For example, I have a data set like this, and I have another data set. When I plot it in a histogram, I am getting it something. See, in this case, I just plotted an histogram. Oh, I deleted it, right? So let's say this is my histogram. So age is 20 to 25 is like, or 15 to 20, and I have another histogram. Bin is something like that. This is 20 to 25-year-old customers, and here I have something like this middle one is 25 to 30, and this is 30 to 35. 35 to 40 is like this. These are the histogram. It's something like a rectangles. Okay, you can see the rectangles. When you join these rectangles by drawing a line, right, at the edges of the rectangles, if you join it by drawing a line, it will be something like this. This is what I'm talking about, right? The spread of this data set. So 20 to 25, at least it starts by 10 here, 10 to 20, 20 to 25, 25 to 30, and this bin is 25 to 30. Okay, the age of the customers in this area is 25 to 30, and 30 to 35 in this rectangle area, this many number of customers are falling here. So when you join the edges of all these rectangles, you get, this is called your spread. How spread out my data. Let's say I have another data set. When I plotted, it looks something like this. I have another data set. Okay, you can ignore this one. Okay, so let me do one thing. I'll just put another data set. This data set is spread is a little bit wider than this one, and I have another data set. That spread of that data set is something like this. Okay, I'll just put this one also as part of this one. So here, so this is data set A. I call this a data set B. This is data set C. What is data set A? This is the one, age of the customers. Okay, age of the customers for, let's say, this is for my January month, and this is the one I call as a data set A. Please concentrate here. Okay, this data set B is this one. In February month, so this is how the age of the customer, if I plot it, I get something like this. And in March month, customers, when I took them and when I plotted it, I'm getting something like this. All these three data sets, whatever you say here, right? So all these, I call this a curve, bell curve. It's a bell curve or normal curve. So all these three data sets are having the normal distribution. We'll explain this one later point in time. So all these three data sets are called in normal distribution form, normally distributed. Okay, I will explain this measures of dispersion or spread with some example. Okay, I will explain this with some analogy. See, let's say you are a businessman. You are doing a business in your village. Okay, in your village. So in your village, apart from your shop, there are no other shops are there. You don't have any competitor. All the customers in your village, they come and buy it from you. Hence, you are feeling bullish. Your business is really doing great job, because in this village, let's say 1,000 people are living. 1,000 families are living in this village. All the 1,000 families come and buy the items from you only. Hence, your business is very good. You don't have competitor. But people from village B, right? It is little far from your village. Few people from this village also come and buy from your shop. But there are some customers, they go to the other town. Okay, that is a little closer to this one, right? So these people are going here, and some customers they go here, some customers they come here. Now you are thinking of setting up the same shop in this village B also. If you set up this, you can attract these customers also to come and buy it from your shop. So what you are doing is, okay, you want to set up a shop here. It requires money to set up a shop. So in that case, what you are trying to do is, first let me go and do a market study in that village, and then let me decide whether I can set up a shop in this village or not. Because blindly, if you go and set up a shop, at later point in time, if you repent, it doesn't make any sense. That's not the wise way of doing it. You decided to go to this nearby village and you want to set up the shop there. Sorry, you want to do a market research. Based on the outcome of the market research or the survey, you want to conduct a survey. Okay, based on that, you will decide whether to set up a shop or not. So let's say you decided to go to the nearby village. Now you are carrying a laptop. Your height is 4.9 feet. You are not tall. Okay, you are just 4.9 feet. You are carrying a laptop, and along with you are taking a data scientist. He is also taking he is also holding a laptop in his hand, and his height is he is also 4.8 feet only. So both of you decide to go to this village. On the en route to village, to go to this village, you need to cross a stream, a river. Okay, a river. You need to cross the river. Only when you cross the river, you can go to this village. Now both your height is right. Both of you are not taller. Okay, and you are concerned. If I cross the river by feet, will my laptops get? Will our laptops will get drenched? So what you are doing is you are calling some passerby. Somebody is walking on that side, and you are calling, hey, can you please help me out? What is the average depth of this river? You are asking him, because only the measure of central tendency. It tells you, hey, the average depth of the river is 4.7 feet only. So he is 4.8, he is 4.9, and both of them think, okay, so since the average, if I go by the average is 4.7 feet. So right, so what we will do is, the average of the depth of the river is 4.7. So if I reach the place where the depth is 4.7, I can keep the laptop on top of my head, so that the laptop will not get drenched. I don't need a boat. We can cross the river by foot. Is that a wise decision or no? Just by knowing the average is sufficient? No, right? So no. Why it is no? Average is alone not sufficient, right? So and then what happened? So you are saying, hey, the average depth is just 4.7 feet. So what we will do is we can go by walk to cross the river. But this guy is a data scientist. He says, hey, let's not make a decision based on the average alone. And he is asking questions like, what is the minimum depth of this river? What is the maximum depth of the river? Right? So, or every 20 feet, every 20 feet length. So what is the first 20 feet? What is the length? Right? And he is putting it in his mind. Okay, first 20 feet, the depth of the river is 1 feet, and then after you cross this position, right? So he is asking him, after every 20 feet, can you please tell me the depth of the river? So then that situation, that guy says, after 2.5 and here 4 feet, and somewhere it is 4.7 feet, and somewhere it is going to be 5.2 feet, and somewhere it is 6 feet. Up to this it is, see, up to this it is 1 feet, up to this it is 2.5 feet, something like this. Okay, and when he explained you initially, right, so 1.0, 1.2 or 1.5 or 2.5, so since majority of the values are smaller, and if you take the average, your average will also be skewed, right? So if you take the average of this data set, listen here also, listen 4. So 1.2, 1.5, 2.5, or let's say 3, and since you have outlier, since majority of the values are very less, only you have few outliers here, or let's say even this one also 4, right? But you have somewhere it is 6. Since majority of the values are very small, only one value is very high, right? It will give you something like the average is 4.7 feet only. Somewhere it is 6 feet. But if you take the average, since your majority of the value is very small, it tells you 4.7 feet. It misleads you. See how important knowing the measures of spread. This is your measures of spread, right? You put each and everything here, each and every data point, and then what you do is you will draw the histogram, or you just draw the line here. The spread is very high. Somewhere it is majority of them is less, and somewhere it is very high. So with this, the data scientist tells you, hey, it is not wise crossing the river by walk. Better will take a boat, because both of us are short. Even if you lift the laptop on top of it, definitely the laptop will also get drenched. The spread of the data is very important. Okay, or if the guy says something like, say, let's say the mean will be there in the middle. In the case of normal distribution, the mean is there in the middle. Let's say the mean is 4.7 feet only, and if you draw the curve, right? So the river starts from let's say 4.6 is the thing, the mean value, and here you have something like 3.5, and here 4.7, right? So in this case, or let's say 4.5, and this is 4.7. So majority of the area of this river falls between 3.5 to 4.7. So all the values, these values are somewhat closer to this mean value, 4.5 feet. Hence it is wise to cross the river. Whereas if you look at this, it's too wide. So you have an outlier here, 6. So since you have an outlier, obviously the data is skewed here. The spread is skewed. The spread is too wide, but if the spread is less, you just remember from with this analogy, you understood we cannot make decision just by using the mean and median. Mean and median alone is not sufficient to make all the decision. In addition to that, you need to know the spread of the data also. So why should I know the spread of the data? So the spread is too wide here. Please remember this. The wider the spread, higher the inconsistency. Inconsistency is very high. Inconsistency is very high. So the lesser the wide, the data is consistent. The measures of spread is very much helpful to understand how consistent the data is. The larger the spread, it is inconsistent. Lesser the spread, it is consistent. Just park this in your mind at this moment. I will explain you with the measures like in central tendency we have used the measures like mean, median. Similarly, measures of spread, there are some measures like a range, standard deviation, coefficient of variations are helpful to measure the spread. So let us start with the range measure. This is what I described, right? So central tendency describes the central location of the data, but it does not tell us anything about the spread of the data. So this is the data set. For this, the spread is less. For the data set C, the spread is very wide. Now let us take a look at the measure range. Using the range measure, we can find out how spread out a distribution is. So look at this data set. This is a data set A, this is data set B. Okay. Are there any difference between these two data sets? Are there any difference exists between this data set and this data set? Say yes or no. Yes, right? It is not exactly same. Here 5, 5 is there, but 10 is there here, but it is 7, 7. It is not same. Why yes? It is not same, right? Now I ask the question, are these two data sets are same? No, it is not yes. It is no. The answer is supposed to be no. The data sets are not same, right? Here 5 is there, 5 is there. Just because a few values are same, that does not mean these two data sets are same, isn't it? So these two data sets are, I just put this one, it's completely different, but there are some overlap. Here also 5, here also 5, and somewhere 20 is the 20, right? So only few of the data values or data points are same, but in total these two data sets are different. But if you find out the range, how do you find out a range? How do you find out the range? You need to subtract the maximum value from the minimum value. What is the maximum value here? 20. The minimum value is 5. 20 minus 5 is 15. That is the range. But here also the range is 15 only. Right? So how do you find out the range? The difference between the maximum and minimum value in your data set. So this one gives an estimate. The range gives an estimate of the spread of the data. Estimate of the spread of the data. So here, so in this case, the maximum value is 20, minimum value is 5 for this data set, okay, and the range is 15. How do you compute the range? Difference between maximum and minimum value. What is the maximum value in the data set? 20. Minimum value is 5, 15. This is the range. In this case, what is the maximum value? 20. What is the minimum value? 5. 20 minus 5 is 15. So in both the data set, the range is 15 only. Though it is different, the spread, the range is nothing but in this case spread. So the spread of the data, right? How spread out the data. Look here, this is a spread, right? This is where spread 15. So this is how using range we can find out the spread of the data set. For example, if I put 200 here, what will happen? Can you tell me what is the range value here? All of you please type it in the chat window. What is the range for this data set? Here 200 is there instead of 20. And what is the range here? Yeah, Deepak, you typed it quickly. How about others? How about others? What is the range here? Can you please make it fast, guys? See, if you concentrate here, if you can answer it quickly, right, we can speed up. Aruna, what is the range here? Can you make it fast? Yeah, 195, right? Why this much of time? Here it is 200, and here it is 195. But here it is 15. But if you look at these two data sets, more or less same only, right? But if you look at 5, 7, 16, or 5, 10, 12, 15, all these values are somewhat closer to 15. Or say, look at this one, right? So all these values are somewhat closer to 20 or so, right? But just because you have an outlier in this data set, it tells you the spread is too wide. Okay, so it is too wide. Let's take another example. So now you tell me what is the range for this data set. All of you please type it in the chat window quickly. Time is precious. Yes, Deepak is faster. How about others? What is the range for this data set? 40, 89, 91, 93. Yeah, 60, right? Correct. So the maximum value is 100, the minimum value is 40. So 100 minus 40 is 60. The maximum value is 100 and the minimum value is 40, hence it is 60. The range is 60. So what does it say? The spread of the data. See, if you plot it, listen, I am going to draw a line here. Where 40 is here, 89 is here, 91 is here, 93, 95, 100 is there here. But almost all the values are closer, though it is closer. For example, now you tell me, is this data set heavily skewed data or non-skewed data? Is that a skewed data or non-skewed data? It is skewed data. So do we have any outlier here? Do we have any outlier here? Yes, Deepak mentioned correctly. So how about others? 40 is outlier. Okay, very good. Because almost all the values are closer to each other except 40. 40 is too far from all the other values. If I remove 40 and you tell me what is the range now? After removing 40, what is the maximum value? 100. The minimum value is 89. What is the range here? 11. Just because I had only one outlier, it tells me something that the spread is too wide. Here in this case, the range is 60. That means the spread is too wide. But is that the reality? No, right? Majority of the values are close by. Just because I have one outlier, it tells me it is here. The spread is too high. That means inconsistencies are there in this data set. That is not the reality. But if I say the spread is 11, So what does it say? If you plot it, the spread is something like this. The spread is just like this. It is not too wide. But it makes us to think, this number makes us to think, oh, the spread is too wide. It is the data set, whatever we have is too much of inconsistency. It is not the reality. The reality is almost all the values are close by except only one value. So with this we are able to understand range is sensitive to outlier. Hence range is, we cannot use range in all the situation to find out the spread of the data. The range shows the width of the data, but it is not showing how it is dispersed between the bounds. It is not the right way of measuring how the data is distributed within the range. So the drawback here of using range is it takes into account of the outliers also. See, all the values are somewhat closer except 40. Just because of an single outlier, it tells me the width of the data is 60. Actually, it is not 60, it is only 11 only, right? Somewhat closer to 11. So hence it is sensitive. So that's where we have some other measures using which we can identify. We can use some other measures. Okay, we have something called standard deviation. Instead of relying on, to overcome this drawback, we can use some other measures. Okay. The application of range. This is the thing. Okay, let's say you have Sony TV. You work for a Sony company. So they have a manufacturing plant in South Chennai and North Chennai. And if you look at this data set, the spread is so closer. Right? The mean is the average number of TVs manufactured in South Chennai. This is South Chennai. The average number of TVs manufactured in Chennai is 50 only. Right, so it ranges, the manufacturer of TV ranges between 48 to 52. What is the range here? 52 minus 48. This is the maximum value. This is the minimum value. The range is, the width of the data is just 5, right? So no, 4. But if you look at this data set in the North Chennai, you could see a lot of inconsistency because the spread is too wide. The range of the TV they manufacture between 40 to 60. Some days they manufacture the TV, some days, right, they don't manufacture it. There is no productivity. Here, they are idle, and suddenly they are manufacturing it, something. So in this case, 60 minus 40. So here the range is, the width of the data is 20. Here the width of the data is 4 only. So with this, the more the spread, the 20 is nothing but the width or spread, right? The wider the spread, lot of inconsistency. There is an erratic, something wrong is happening here. People are not working consistently. Sometimes they are working, sometimes they are not working. Sometimes, right, they work, they produce little output. Only one TV they are manufacturing, and rest of the day they don't do anything. Suddenly they do something, right? So here, lot of inconsistencies are here. The consistency, using range we can identify the width of the data. We can find out the spread of the data. It is also helpful to understand how consistent the data. But the challenge with this one is, if you have an outlier, it is not. It is taking into account of the outliers also. That is one of the drawback with range. So in statistics, using range, we can obtain the difference between the maximum and minimum value. This value gives us an estimate of the spread of the data. Please remember this. So range is computed by taking the difference between maximum and minimum value. Next, we will take a look at another measure of spread called standard deviation. So it is already 1:30. Okay, so we will wrap up as of this one. We will continue next week. Probably from next week onwards, right, we will increase the timing by 1.5 hours, 1.5 hour, and it will be